Your heart just continues to beat over and over. And so we need material properties in these therapeutics that match those functions.
If we try and apply our classic brittle hydrogels, they'll just fracture and fall apart. So now what we might be able to do is apply these very strong hydrogels and mechanically support them. Now we've come up with an extremely simple way to 3D print hydrogels and achieve these incredible mechanical properties.
In the end, our ultimate goal is to make these new therapeutics and be involved in the process to translate them into clinical medicine. Tissue adhesives are great importance for a lot of applications where it really bonds that material onto the tissue and then withstands that loading. So we need to maintain that interface between the biomaterial and the tissue. And to do that, we need materials that have specific properties of their mechanics that then can withstand that loading, dissipate that load, and not undergo failure.
The idea would be that we would attach this to the heart and it would be able to undergo the cyclic stretching and expanding of the heart.
So our hope with this would be that this is a simple processing method that a lot of people could adapt to in their own academic labs as well as in industry to improve the mechanical properties of any of the hydrogels or elastomers that they're trying to process with 3D printing. We're really excited about using this technique to improve the mechanical properties of those hydrogels and use a variety of different applications.